Hello everyone! Today I'm going to talk about the project we did using car engine using Daisy Lab software. These are my teammates. Now let us go to the introduction. The project goal is to create a system that stimulates instruments by gathering, processing and analyzing sound data from the transducer in the frequency and time domains using Daisy Lab software. It focuses on the important role that microphones play in signal analysis across a variety of domains. The principle of application. A microphone's primary function is to transform sound waves into electrical impulses. It is a sensor or transducer which converts sound into electrical impulses. A diaphragm that is responsive to sound waves, which are waves caused by pressure in the air, is used to do this. The movement of the diaphragm is converted into electrical signal that may be amplified, transmitted or recorded. The example of the microphones are electrodynamic microphone, piezoelectric microphones and condenser microphones. Application of microphones in industry. Microphones used in industrial applications are designed to withstand harsh environments while maintaining reliable performance. These microphones are typically rugged and durable, capable of operating in extreme temperatures, high humidity and noisy conditions. They are often used for monitoring machinery, detecting fault, or enabling communication in industrial settings. These are the complete sensor system, which is sensing element, signal conditioning element, signal processing element, then it goes to data presentation element. Now let us go to chapter 2. The theoretical underpinnings of acoustic management are briefly reviewed in this chapter. Theoretical background. Sound perception arises from vibration transmitted through a medium. Usually air is measured with instruments like sound level meters. Sound travels as pressure waves caused by compression and expansion of the medium. The simplest vibration is sinusoidal, representing a pure tone and forming the basis of complex sounds. This is the formula for sound pressure level, which is often described as SPL. For Daisy Lab is Data Acquisition System Laboratory is generally a graphical programming software used for data acquisition, measurement and control. It is designed for engineers, scientists and researchers to easily configure and visualize data collection system without the need of traditional programming skills. A data acquisition system using a microphone includes several key components, which is the microphones capture sound waves and converts them into electrical signals, typically using a sensitive condenser microphone. In acoustic measurement, there is the sampling rate, digital filters, and fast Fourier transform. Now let us go to the chapter 3, which is the experiment. The materials and equipment used. The car engine is used to test, while the built-in microphone in the laptop is used to record the sound of the car engine. The Daisy Lab software is used to measure the time domain and frequency domain of the car engine. The Decibel X app is used to measure the decibel of the car engine. Now let us do the Daisy Lab setup. Before that, make sure to do the measurement setup. The first step, open a new worksheet, select the analog input module option from the input-output tree and then start using the Daisy Lab application. Second, connect the analog input module to a digital meter to measure the VRMS that will be used in further searches for the dB value. Decimal numbers are now shown. Third, attach the digital meter to the formula interpreter module of the mathematical tree. Fourth, to determine the car engine decibel level, it is then linked to an additional digital equipment with the same setting. Fifth, include a write module in the software to store all the collected information. Sixth, between the analog input and the digital meter, a second flow will relate to the YT chart module to measure the time frequency. Last but not least, include a data window to stop the data leaks. This is the Daisy Lab layout that I explained just now. Now let us look at how the experiment is conducted. Now let us go to the results and discussion. The peak VRMS value we obtained from the Daisy Lab data is 0.3088 volts, while the decibel value we obtained is 64.97 dB. Not only that, let us not forget about the decibel value from the decibel XF, which is 64.4. This is the time domain plot and the frequency domain plot that we gained from the DaisyLab app. Now let us go to the discussion. The decibel value we got from the decibel XF is 64.4 dB, while the decibel value we have gotten from the DaisyLab software is 64.97 dB. In this, we get 0.88% difference. This shows both the app shows a very accurate value, but sometimes the value can be different because of the unwanted noises out. So the solution is sometimes we can use filters in the DaisyLab software. While analyzing the graphs, there is a sudden fluctuation in the frequency domain graph. The spike indicates the presence of rotating equipment within the car engine. This is due to the engine operation as the motor generates vibration and noise at a specific frequencies. By examining the graphs, we observe smaller peaks following the dominant one, which could suggest the presence of harmonics. So overall, this experiment was a success because of the error rate is very low. Finally, let us conclude. In conclusion, this project successfully demonstrates the use of DaisyLab software to measure and analyze acoustic signal from the car engine, showcasing the effectiveness of virtual instrumentation in sound data analysis. By integrating a condenser microphone as a primary sensor, the system accurately captured and processed engine sound data in both time and frequency domain. The results reveal significant insight into two engine operations such as domain frequencies, harmonics, and noise pattern, which high accuracies validated by the comparison between the external decibel measurements. This approach highlights the potential for employing such system in diagnostic and monitoring applications, offering a reliable and efficient method for analyzing mechanical acoustic signals. And this project really made us to know the importance of measurement and instrumentation in daily life. By repeating the experiment at least 3 times, will be given more accurate data, and it is best to conduct this experiment in a very quiet area away from the noises to make sure the data is much more accurate.